All right, good afternoon, everyone, and welcome to Co-Digestion of Food Waste at Wastewater Treatment Facilities, leveraging existing infrastructure for organics diversion. I'm Megan Schultz-Fontes, Executive Director at NERC, Northeast Recycling Council, and very excited to welcome you here today. Before we get started, I'm just going to review a couple of technical logistics in case you haven't been to one of our webinars before. This is being recorded, and if you have questions, there should be a Q&A box at the bottom that you can find to submit anytime during the event. Towards the end, we'll have some time for questions and answer with the speakers, and they'll also, if they can respond more earlier on, they will. We will provide all the presentations and the recording to you after the event, and it will be on our website as well. Really briefly about NERC, we are 11 states united in a mission to minimize waste, conserve natural resources, and advance a sustainable economy. We do that by providing educational free webinars such as this. We have training courses. You can explore all of that on our website. We also develop many resources. Most recently, we have a policy position on chemical recycling, just as an example. And we also do a lot of collaboration between our state and advisory members on various committees and through our annual conference each year, Rethink Resource Use. Today's agenda is I'm going to kick it off momentarily to our moderator, Deborah Darby from Tetra Tech, and then we'll hear presentations from our three expert speakers here today. And then we will have our Q&A session. These are our lovely speakers, and now over to you, Deborah.
All right. Well, thank you very much, Megan. And as Megan said, I am Deborah Darby, the Organics Practice Lead with Tetra Tech's Solid Waste Solutions team, and I'll be serving as the moderator today. Just to kind of set us up, co-digestion represents a unique intersection of waste management, energy recovery, and climate action. In today's session, we will explore how utilities and communities are leveraging this approach to advance sustainability goals. So I want to thank everybody for being here today, and let's just dive in, and I'll introduce our first presenter. Janine Burke-Wells is the Executive Director with the Northeast Biosolids Residuals Association. Prior to NEBRA, she worked as a public servant for over 3 decades, 10 years with the U.S. Environmental Protection Agency, and over 20 years with local government, where she managed several wastewater systems in Rhode Island. Janine led the City of Warwick's Sewer Authority's response and recovery from the 2010 flood that wiped out the treatment facility and numerous pump stations. Jane has a degree in chemical engineering from the University of Rhode Island and a Master of Public Administration from Northeastern University. So please welcome Janine.
Thanks so much, Deborah. And yeah, thanks to NERC for hosting this. NEBRA is a NERC collaborator, and we have a few things we're hatching up right now. But we definitely have some common interests when it comes to organics and nutrient recycling. So I'm glad you're taking an interest in biosolids, which is a very unique organic waste that presents a lot more challenges in recycling, I would say. So I'm going to introduce the topic of co-digestion today, and then you're going to hear from some actual anaerobic digester, co-digestion operators. So why are we talking about co-digestion? Well, it addresses 2 waste streams with 1 process, so that's a bonus. It absolutely reduces volumes. It increases energy or biogas production when you mix food waste with biosolids and sludges. By creating this energy and these sources of power, it improves the resiliency and self-sufficiency at water resource recovery facilities. Co-digestion is a perfect example of a clean water economy, a circular water economy practice, and I'll more on that in the next slide. It offers financial opportunities and benefits for the community. And in some ways, I feel like it's a uniquely urban solution. And you're going to hear from New York City. Can't get more urban than that, and what they're doing with co-digestion. Just As far as the traditional kind of core objectives for anaerobic digestion, the main uses were to control pathogens, reduce vector attraction, and obviously the volume reduction. And when we look at it under a circular water economy, as a circular water economy practice, the objectives are expanded to include nutrient recovery like phosphorus, struvite recovery, energy recovery, co-digestion, reduced environmental impacts, and reduced carbon emissions. So that's a really good reason to look at co-digestion. I'm a big Water Environment Federation member, and I'll just share with you their definition for the circular water economy. And one of the biggest surprises to me when I started focusing just on the wastewater solids was how much resources there are to recover from the solids. And if you think of this as a kind of as a water cycle, where if you don't put things in, you don't have to take them out at the end. So kind of thinking about products and things we use with the end in mind. That's what we're talking about when we talk about the circular water economy. So more on the recover piece here. These are the different aspects of that recovering resources. So water reuse, some of these we're pretty familiar with. And I mentioned the nutrients, and now especially the energy recovery from sludges and biosolids is a huge component of the circular water economy. All right, this is a what they call a graphical abstract from a paper that I'm co-authoring that we're hoping to get published soon. But what we did is we looked at not just biosolids, but food waste and other organic materials in the U.S. that are generated in the U.S. and try to turn it from a linear economic model to a circular water economy model. And so what we did was try to calculate the value of those wasted resources that we could recover if we had the technology and the money to do so. And so biosolids are just a small piece of that. If you include all the organic wastes that we generate, including manure, food wastes, etc., we could supply 93% of our nitrogen fertilizer needs in the U.S. and more than fourfold the amount of phosphorus that we need. So this holds great potential in addition to generating electricity and sequestering carbon, as I mentioned before. And so this paper is kind of a policy paper, and it calls for a national biosolids innovation hub and a national resource recovery plan. So it kind of goes all together as far as biosolids or other organic residuals. So, and in case you didn't realize, there's all kinds of things you can recover from biosolids. We're pretty good at removing struvite now, but other products from pyrolysis and gasification like biochar. There's products from arrested anaerobic development like biodegradable plastics. You can generate hydrogen gas. It's a very exciting time to be talking about recovering resources. All right, so a little on anaerobic digestion at water resource recovery facilities. I mentioned the primary purpose why we have these processes is for compliance, to reduce the volumes and to meet the requirements, the federal requirements for stabilized sludge. We're very familiar with this. This is a process that we've operated for a long time. We've often used to run combined heat and power systems. There's some flaring involved with this. We could talk a little bit about, I think Jane might mention about leakage and other things that we need to pay attention to when we operate these facilities so that we don't have unintended impacts. Dewatering solids, I mentioned that because oftentimes the research shows that anaerobically digested solids are a little harder to dewater, but interestingly, when you combine it with food wastes, it actually improves the dewaterability. So I'm just going to mention that. And, as a bonus, when you take food out of the collection system by collecting food, fats, oils, and grease and things like that, you also protect the collection system as well. So that's a bonus. And on the other side, I've gone ahead and taken a look at what there are for resources, existing anaerobic digesters at water resource recovery facilities in the NERC region. And yeah, I stand corrected. I didn't think there was going to be this many of them So there are quite a few out there, and I guarantee you there are some abandoned ones that are out there. But when I ran the treatment facility in Warwick, we had 2 digesters that had been built in the 60s with federal funding, and once we got stringent phosphorus limits, that we stopped using it. And I guarantee there's more of those abandoned resources out there. So just quickly, where does this all fit as far as EPA's wasted food scale? It's kind of hanging in the middle of the P trap there, but it's certainly after you prevent and then donate or use it in some other way, anaerobically digesting and composting it is a good thing to do. All right, so some of the questions I came up with, and maybe Jane and Andrew will answer some of these, but some of the issues are making sure that these units are in the right place for the right purpose and minimizing impacts on the public. I'm pretty sure that the traffic is the reason why the Massachusetts Water Resources Authority doesn't do co-digestion. That's their famous egg digester in the background there. What to do as far as accepting waste? You have them shipped in. Do you process them on site? What do you take? This is probably the most critical piece of it, is the feedstock quality and quantity. And then, not a bad problem to have, but what do you do with that additional energy that you're creating? And then, of course, for us, the biggest question is always what happens with the remaining solids. You know, the end uses, the capacity for managing those remaining solids is diminishing every day. So knowing where those are going before you start is really going to be the key. Just a few things of interest from NEBRA. We run the Northeast Digestion Roundtable. It's free. It's an open quarterly roundtable to talk about operating issues with specifically co-digestion lately. So that's open to all. We also manage the biosolids emissions assessment model, which is looking at co-digestion as far as greenhouse gas impacts. And that's where we're finding the leakage to be a topic of discussion. We're also collaborating currently with UConn School of Engineering, which is basically developing a SCADA system, which a supervisory control and data acquisition system for operating anaerobic digesters. These have been historically tough to operate. You need a good operator who knows what they're doing. And so maybe some computer assistance will really take us to the next level with co-digestion. We're involved in International Biosolids Association, and I just mentioned that because they're doing a lot in Europe and other places, more so than we are with co-digestion. And then we have a lot of members who design, build, operate, and maintain these. So feel free to check out those resources. And then before we kick it over to the actual operators of the co-digestion facilities, I'll just give you a few of my takeaways. From what I see, there's a lot of capacity to take on food waste at existing and maybe abandoned anaerobic digestion facilities. There's limits, and Jane, I'm sure we'll talk about that. You can't take 100% food waste or even 80%. Co-digestion is really not a one-size-fits-all. And I like to say this, every treatment facility is different. Every sludge is different. It depends on what you have there in the community. So the same goes for co-digestion, and you need to really take a look at it before you commit. It is expensive to build from scratch, but I feel like with the price in the market lately for end-use disposal, that it could be affordable on a much smaller scale under current market conditions. And as I mentioned, the biosolids and sludge market is stressed, so we need any and all strategies. I feel like anaerobic digestion is the best volume reduction strategy for a lot of reasons, but feel free to argue with me. That's fine. And we didn't even mention farm digesters. We're just talking about infrastructure at existing infrastructure at wastewater treatment facilities. So I'm optimistic about food capacity. I like what I'm seeing in some states as far as diverting it to anaerobic digesters. And yeah, things are looking up for co-digestion. I'll turn it back over to Deborah, who can introduce our next speaker then.
Mhm. All right. Janine, thank you very much for being our opening presenter. There are a few questions in the Q&A, and I believe we're going to try to answer most of the questions after our three presenters. But I think, Janine, though, there was one question. How do you join the New England Digestion Roundtable?
I will put a link to the Netter site right in there, and yeah, you can just sign up and join us on a quarterly basis.
Okay. And then there was Allison who's driving. Yes, the presentation is being recorded, so you'll have access to this webinar later. So, all right. Thanks, Janine. Our next presenter, we have Jane Gajwani. She is a professional engineer with nearly 30 years of experience working in the intersection of water and energy. And as the director of the Office of Energy and Resource Recovery Programs and the agency chief decarbonization officer for the New York City Department of Environmental Protection, she and her group are tasked with plotting the course for the agency to achieve both carbon and energy neutrality. And prior to joining the DEP, Jane developed greenhouse gas and energy reduction strategies on the municipal, regional, and national levels within the water and waste sectors. And Jane has both a master's and a bachelor's degrees in chemical engineering from Cooper Union. Jane?
Hi, thank you so much. I really appreciate it. And so many thanks to NERC for putting this on. And I'm really delighted to be here with Deborah and Janine and Andrew to talk about this because we're pretty excited about it. Just a little bit about New York City Department of Environmental Protection. We are the water and wastewater utility for New York City. We're the largest combined water wastewater utility in North America, delivering 1.1 billion gallons of water to 8 million New Yorkers every day. We treat about 1.3 billion gallons of wastewater a day on average, because we also handle stormwater. And that includes operating 14 in-city wastewater resource recovery facilities. And across those 14 facilities, we have a fleet of 75 anaerobic digesters. We also do resiliency. We manage the city's coastal resiliency planning and implementation of green infrastructure to mitigate stormwater flooding. And we're also responsible for air, noise, and hazardous waste. DEP is really committed to deep decarbonization and a circular economy. We've been working on deep decarbonization since 2007 when the first Plan YC came out. And through a combination of mayoral directives, executive orders, the Climate Mobilization Act of 2019, and DEP's own strategic planning goals, we have been tasked with achieving carbon neutrality by 2050 with interim milestones of a 40% reduction by 2025 and a 50% reduction by 2030. Achieving energy neutrality at our wastewater resource recovery facilities by 2050, achieving zero biosolids to landfill by 2030, and also achieving a circular economy. So I just want to tell you a little bit about Newtown Creek. This is the largest of our 14 in-city wastewater resource recovery facilities. It's a 310 million gallon per day treatment facility. It's sited on 54 acres in Greenpoint, Brooklyn, and it has 8 egg-shaped digesters, each one that's able to hold about 3 million gallons. So we have about 24 million gallons of digester capacity at this particular facility. And we have a lot of spare capacity. The target residence time in a digester is typically 15 to 20 days. Our retention times are typically 35 to 40 days in this digester, so we actually have plenty of room to take in other feedstocks. So Newtown Creek is the city's first facility to export renewable natural gas created from wastewater and food scraps. We currently have a program with Waste Management that's been operating since 2016, where Waste Management delivers to us about 200 to 250 tons per day of pre-processed food scraps. It's brought in through a Vector truck. It's delivered to Newtown Creek. Co-digestion is the process of, we do anaerobic digestion of our wastewater sludges. Co-digestion is the process of putting other feedstocks alongside that, such as these food scraps, to have it digest within the same environment. We also have a collaboration with, or an agreement with National Grid, which is our local natural gas provider, where they take all of our excess biogas and they clean that up to natural gas standards, and they export that to the natural gas pipeline. So all excess biogas that would ordinarily be flared after we've met the heating needs of the plant is now being put onto the pipeline for beneficial use. So just so you can see some snapshots of what this looks like. In the first picture, you can see the collection in New York City. There's two different types of collection that happens. About half of it is collected by the Department of Sanitation, and that's for the residential part, and it also picks up from schools and other types of facilities like that, municipal systems. And then there's also the commercial sector, which handles the other half of the municipal waste stream. And then the source separated organics are brought to a transfer station that Waste Management operates about a mile from the Newtown Creek facility, and they pre-process it. They pick out all of the contamination. It goes through a 5-step process where it gets cleaned and it gets turned into a slurry. I had a colleague who would refer to it as a smoothie, probably the most disgusting smoothie you can possibly imagine. It's very smelly, but it has that kind of consistency. And what's really important to us is that it's clean of contaminants, and then also that it's pumpable, because we have a wet anaerobic digestion system. They put it into Vector trucks. You can see that in number 3, and they bring that the mile over to Newtown Creek, and then it gets put into a feed-in station, a storage tank that then gets fed into our wet well, and then gets put into the digesters. It goes through the digestion process. Typical retention times, as I said, are around 35 days. This particular facility, the biogas is then put into a gas holder. It's preferentially sent to our boilers to be used for heating needs, which includes heating the digesters themselves, and also seasonally for building heat. And then any excess biogas is then sent to, in number 5, you can see that's National Grid's gas cleaning system. They have a pressure swing absorption system that takes out, kind of all the contaminants. It takes out siloxanes and sulfur, and also the carbon dioxide. That's kind of a really normal part of biogas. And so it cleans it up to natural gas standards, where it's almost completely a methane stream, and then it gets tested and odorized, and then exported out to the natural gas grid to be a 1-for-1 offset to fossil natural gas. We've gotten actually a lot of attention about our food waste system. Like I said, we take about 200 to 250 tons a day. And I think some people think that this is actually like the bulk of what's in our digesters, but really it's only about 10% of the feed that what we're putting into our digesters. Newtown Creek is a very large facility, and so we have a lot of wastewater sludges that are being digested every day. And so, adding this in does add to the production of the biogas, but it really is kind of just a part of the feedstocks. And I will say that one of the positive things that we find about this is that, if there's any kind of variation in the food waste that we're receiving, or if there's any reason why we need to ramp it down or ramp it up, the wastewater sludges that we receive every day and we're digesting every day really provide great buffering capacity. So it's easier for us to kind of ramp up and ramp down. So why are we doing all of this? So just for some context, Co-Digestion, we believe, plays a pivotal role in managing New York City's source-separated organics. We have a lot of digesters within the city. We have a good amount of spare capacity, and we produce a lot. As a city, we produce a lot of food waste, right? So it's estimated that about 4,100 metric tons per day of organic waste is generated. It's about 1/3 of New York City's municipal solid waste stream is organic. And so that includes food scraps, yard debris, and restaurant grease. So there's a lot of material that needs to be handled. New York City has recently rolled out the largest curbside organics collection program in the nation. So every single New York City resident has access to free curbside organics collection, which is really exciting. And then also New York City commercial organics rules require certain large-scale businesses to separate organics, and that's been a pretty successful program. And then it's expected that the Department of Sanitation will expand that to cover all commercial businesses by 2026, which is very soon. So there's a lot of material to be collected, and as the program matures, we anticipate that more and more will be collected. And we're finding that it digests really well. Like I said, we've been doing this since 2016. And, initially we were a little bit nervous about it. We're wastewater people. We treat wastewater sludges, and anaerobic digestion is something that we've been doing for a really, really long time. Decades of, as Janine covered, it's a really important aspect to large scale centralized wastewater treatment. And we were a little bit nervous about, if we're going to add this other feedstock to it, is it going to, turn the digester sour? The digesters in Newtown Creek are very large. We wouldn't want to have, kind of 24 million gallons of sour digestate on our hands. And so we were very, very cautious with it initially, but we were really surprised, this stuff digests really, really well alongside alongside our wastewater sludges. And it took us a while to really kind of think it through. And there's some things to consider in this, is that, food waste is majority water, right? And so it's actually this is kind of, just part of the water treatment process for the water that's in the food waste itself. And then also, one of the things that we were really impressed with initially is that the food waste digests at really well at the same temperatures and the same residence times as our wastewater sludges. And it took us a little while to kind of put together that the material that we're receiving as food waste is pretty much the same material that we're receiving as wastewater sludges. They're both food waste, right? The food waste that we're receiving through the wastewater stream has been digested through people the first time. And so what we just have is two streams of the same material, except one has been digested the first time around and the other one is not. And the results of this is that the biogas yield of the food waste is very, very high. So we typically see about half of half of the solids of a wastewater sludge convert to biogas. With the food waste, we're seeing over 75% of it convert to biogas. So it's really, really good at creating biogas. And then the resulting biosolids, the material that doesn't turn to biogas, the digestate that's left, is a nutrient-rich resource that can be a valuable soil amendment. So most of DEP's biosolids receive additional, kind of treatment off-site prior to land application. Post-processing, we do drying, we have lime stabilization, we also do composting. So there's kind of different endpoints that we have. And then those biosolids are commonly used for, agriculture, mine land reclamation, and other types of ecosystem restoration. So for Newtown Creek specifically, like I said, 75% of the food waste is converting to biogas. About 5% right now is going to land application through contracts that we have, and another 5% is currently going to landfill, but that should actually, through changes or kind of not renewals, but with new contracts, that beneficial use contracts that we're putting up, we expect that is going to also go to land application. And then we have an agreement with the Passaic Valley Sewerage Commission, which they take a certain amount of our digestate, and they use the Zimpro process on it, and then they use that for landfill daily cover. But they're also working on a plan to move more biosolids to beneficial use. And it's been really great, from a climate standpoint to do this work. And so, like I said, we at Newtown Creek, we are creating renewable natural gas, and that's a direct replacement for fossil gas. So every molecule that we're able to recover and put out into the natural gas grid is one less molecule that's going to be dug out of the ground and kind of introduced into the carbon cycle. And then, of course, the emissions reduction of diverting so many food scraps from landfills reduces a tremendous amount of methane. And so we've calculated, so the amount of RNG, renewable natural gas, that was produced in 2024 was enough to heat 5,700 homes. And we've calculated that the reduction in greenhouse gas emissions is about, in 2024, was about 28,000 metric tons. And that's about the equivalent of building 71 central parks, or not building, but planting 71 central parks, or the equivalent of taking about 6,700 cars off the road. So it really, this is, with just the amount of food waste that we're receiving, there are really significant carbon mitigation benefits. Northern Tilth did a study in 2023 where they looked at the carbon footprint of anaerobic digestion and compared it to other food waste endpoints, and essentially comparing it to compost, but also looking at different iterations of anaerobic digestion, and found that they were all carbon negative, and that anaerobic digestion, when partnered with having beneficial use of the digestate, is really kind of comparable to composting. And even if you were to landfill the digestate, it's still net carbon negative, or close to net carbon neutral. And all of this is in stark contrast to if we continue to just send it to landfills, which is definitely net carbon positive. But we want to make sure that everything that we're doing here really is mitigating climate change. And so we've committed extensive resources to mitigating any fugitive methane emissions that might be occurring at our 75 anaerobic digesters. We conducted field studies across 14 in-city wastewater resource recovery facilities, looking for fugitive methane, and we did identify some leaks. And so many of the identified deficiencies were quickly resolved by the facility. Some of it was like, oh, we just need to tighten this, or we might need a new gasket, or there were things that were actually pretty easy to mitigate. And then also there were, where we have ongoing construction projects, we were also able to add some of the scope of work into capital projects that were slated for implementation so that we could get it done quickly. And then the remaining items, New York City is investing about $27 million toward fast tracking contracts to replace lengths of pipelines and other places where we're finding leaks, to make sure that we're able to mitigate as much methane as possible. And we're also seeking to have resources dedicated so that we can do this type of routine detection, measurement, and resulting upgrades to the gas handling infrastructure to make sure that we really are achieving the greater environmental good. Just wanted to touch a little base on it. So New York City generates about 4,100 tons a day of food waste. We're processing about 200 to 250 tons a day. I think a little bit more than that is currently being composted. And we really do see co-digestion is an important solution for New York City, but it's part of the toolbox. And we think that co-digestion and composting can definitely be complementary. And so just things to consider, between co-digestion and composting, that, co-digestion is able to take a different kind of range of organics that are collected, that we're able to take in addition to food scraps. We can also take meat and dairy. We can take fats, oils, and grease. Composting is, again, great for its food scraps and also for yard debris. Although we can take yard debris, it doesn't digest quite as well. And so we prefer that to be routed to composting when possible. The ability to address contamination, levels of physical contamination in the source separated organics in New York City's collection is uneven, right? Like there are certain, I think the drop-offs that we receive from the farmers markets, that tends to be really pristine source separated organics. We have, other waste streams where the other source separated organic streams where the contamination can be over 20%, 30%. The wet process of to pre-process the food waste to go to co-digestion is really, really effective of cleaning out that physical contamination. I think that can be, from what I've heard, is more challenging for composting, but I do know that large scale facilities, do have the ability to do it. But it is something, the process that we have, we've measured the inerts after the pre-processing step, and we find it very effective. For community benefits, if you're able to kind of, like we're doing, put this in tandem with a gas to grid system, it actually reduces on-site air emissions and air pollution because it's reducing the overall amount of flaring that we're doing at the facility. And so we think that that's a great kind of local benefit to our neighbors next to our wastewater treatment plants. Composting, I'm a huge fan of community composting. It really provides hands-on educational opportunities and can support community gardens. Like there's just really so many wonderful things about composting that helps build communities. Footprint, co-digestion is able to handle a tremendous amount of material in a very small footprint. It tends to be very vertical. The footprint, as you're probably all aware, the footprint for composting can be quite large because it is a much more of a horizontal process. And then the timeframes are different. So co-digestion takes about 15 to 30 days. Composting, by contrast, can take 3 to 6 months. But again, it really is kind of, I think it's going to take kind of lots of different solutions in order to handle the total amount of material that the New York City is generating every day. Just a little bit a note about renewable natural gas. The work that we've done trying to figure out like really what is the highest and best use of our biogas for New York City has pointed to directing the renewable natural gas to the hardest to electrify users is the most sustainable way for us to have our biogas used. And just for context, there sometimes is some concern that we're kind of perpetuating the natural, fossil fuel usage, and it really isn't the case. Like if we were to take all of the city's food waste and we were to digest that and we were to take all of our wastewater biogas and export all of that to the grid, we might be able to offset like 2% of natural gas usage. We are not, kind of perpetuating. Everybody will need to electrify their heating needs who can electrify their heating needs, but there are a small number of niche users that it's going to be really, really hard for them to get off of fossil fuels. That they need higher temperatures. There's just no room to kind of, to be able to get off the Con Ed steam system. There's these niche users within New York City that our RNG can be directed toward them because they're going to be the very last users of fossil fuel in the city. There is, it has a negative carbon footprint. Not all of them are the same, but you can see from Argonne National Labs, the RNG that comes from sludge and from food waste are both considered net carbon negative. And again, very much in stark contrast to fossil natural gas. So just some key takeaways. We believe that a local outlet capable of managing large volumes of material can help ensure the success of New York City's residential and commercial organics collection program. We are hard pressed to find, really local composting sites that would be able to handle just the volumes that New York City presents. And we're able to handle a tremendous amount of material within existing infrastructure, leveraging, decades and decades of experience from our wastewater treatment operators. The resulting digestate can also be used for beneficial use, since we are still recovering the nutrients. Like Janine had said, we think that co-digestion is especially well suited for urban areas. Many wastewater utilities already operate anaerobic digesters. Urban areas generate significant volumes of food scraps and fats, oils, and grease. And this pre-processing equipment can effectively handle high levels of physical contamination. And then just lastly, like I had mentioned, the renewable natural gas production from waste-derived feedstocks can complement electrification efforts in order to achieve decarbonization goals. It should be similar to how, that co-digestion can be part of the toolbox. It includes lots of composting. We think that RNG can be used as part of the toolbox for, along with a lot of electrification for a city to decarbonize its heating needs. So thank you very much. I'll hand it back to Deborah.
Okay, thank you very much, Jane. We do have a lot of questions in the Q&A. Most of the questions we'll respond to after our last presenter, but I do have a question, Jane, that I would like to ask you. It's regarding a typical solids concentration for the slurry. What's your upper end, if you will, of solids concentration that makes the slurry still pumpable?
Yeah, so we've been handling, it's typically right now we're receiving around 8%, but with the upper end that we've seen is around 16%. And I think that it could be pushed a little bit farther, but I'm not clear exactly how much farther. I know it's one of the things that Waste Management is working on.
Okay, and there was one question regarding the waste management, the partnership. Um, how did that get started, and what's the timeline of a partnership like this?
Yeah, I'm sorry. I'm trying to like shut my screen without showing my.
That's okay. Want me to re-ask that question, or
No, no, so sorry. Yeah, I can tell you about that. So for with waste management, I think that they actually had approached the city. They kind of saw that we had these digesters that had spare capacity. They had a waste transfer station, nearby. And, quite honestly, it's something that they wanted to try out. They had kind of done some work on this, and we thought it was a good idea given that we had this spare capacity. But the agreement itself was a demonstration, right? And so it was, and then eventually became a concession agreement. And now through a negotiated acquisition, we actually collect like a cost offset to help pay for the biosolids that result from it. But yeah, it's been a very successful collaboration with waste management. That they invested in their own system, right? That at their transfer station to do the pre-processing, and then they also built the feed-in station, and then they own and operate that whole piece. And then then we take it from the point we take the pre-processed food waste from their feed-in station into our system.
okay, super. Thank you, Jane. And terrific questions are coming in, but again, I'm going to try to hold most of them until after our third presenter, who I'd like to introduce next, Mr. Andrew Opperman with Oneida Herkimer Solid Waste Authority. Andrew is a professional engineer. He's been working with the Solid Waste Authority for over 13 years, and he's responsible for construction management, facility safety, and operational oversight. Andrew has overseen improvement projects for recycling, processing, landfill operations, and the development and construction of the source separated organics processing facility, and we'll learn more about that next. And Andrew graduated from Rensselaer Polytechnic Institute with a bachelor's degree in civil engineering and a master's in systems engineering and technology management. So Andrew, it's yours.
Yep. Thank you, Deborah. Good afternoon, everybody. As she said, I'm with the Oneida Herkimer Solid Waste Authority. We are located in Utica, New York. This presentation was with another member of our partnership here, Dale Lockwood. He runs the wastewater treatment plant next door to our facility, and he contributed that portion of the presentation. So just to give you an idea of what, as the authority that we do, we were formed in 1988. We're a public benefit corporation. We serve about 300,000 residents. Our largest city, located in Oneida County, is Utica, which is just under 65,000 residents. You can see on the photo there of New York State, those are the two counties that we service, Oneida and Herkimer counties. We only take trash from those two counties, and we operate our landfill based on that. We have a total of 10 facilities throughout 3 locations, and we service 74 cities, towns, and municipalities. Those are just some of our programs that we run. Recycle one and done, single stream recycling. And then why everybody's here today is our food to energy program through our source separated organic waste processing facility. Some more information about us. We run a recycling center in Utica. Also have an eco drop for residents. Household hazardous waste facility that we run on a seasonal basis. Operate a landfill up in Boonville, New York. We have 3 solid waste transfer stations. We have a second eco drop at our second transfer station location in Rome, New York. We also operate a green waste composting facility where we only take green waste. Currently, this is subject to change, but we currently have a landfill gas to energy facility at our landfill. And then last but not least, that is a picture of our food to energy facility in Utica. Let's give you a brief overview of the Oneida County Sewer District. This was Dale's employer. It was formed in 1965, and they are responsible for a portion of Oneida County Sewer District. They've got 45 miles of interceptor sewers, 2 main pump stations, Sequoia Creek and Barnes Ave, and the County Water Pollution Control Plant, which is located in Utica, New York, too. It treats wastewater from municipalities throughout the county, and I will show you in this slide here. That is the portion of Oneida County that they take care of. So I'll go back, just kind of show you. If you look on the map in the top right, right next to the left of that H in Herkimer, that is the little area that they control for their sewer district. So this is a aerial view. This was taken about 3 years ago. We are located above this lime green line. You can see our recycling facility. It's 2/3 of the building. Transfer station is on the right. And that arrow here is showing our SSO, food waste and depackaging facility. In the back, at the very top of the screen, that is our green waste compost site. And then the majority of this picture is the wastewater treatment plant facility that is next to us. You can see on the lime green line is a food slurry force main. That is how we send the slurry to the anaerobic digesters next door. So for the authority, we control what is above that lime green line, and then Oneida County Sewer District is below that. They had a major construction project going on over the last 8 years. We'll get into that too, but I just want to give you a general overview, as probably going to go back and forth in between this photo. All right, food to energy. That was the name of our program that we came up with. We process the food, we send it to Oneida County Sewer District, and they create energy with it. Our facility is called the Source Separated Organics Processing Facility. The acronym is SSOPF. You'll see that appear in the upcoming slides here. So we originally did a feasibility study back in 2017 to see how much organic waste that Oneida and Herkimer counties could provide to our facility. Based on that, based on the ranges of how much weekly tonnage they come up with, because at the time DEC was exploring coming up with 2 tons per week, and then they've been ratcheting it down to 1.5 tons now, and then I believe in 2027 it's going to be down to 1 tons per week that they need to recycle their organic waste. We began processing in June of 2019, excuse me. We built the facility in 2018. And currently we receive SSO from local grocery stores, colleges, food banks, and dairy manufacturing, and some residents do bring our materials. You can see on the right, that is all prepackaged food. We take prepackaged food, and we also do take loose grocery store waste. To date this year, we've had some equipment updates and upgrades in the beginning of the year, so we weren't operating for the first couple of months, but we've processed just under 6,000 tons of SSO this year. Our annual tonnage since 2019 has grown anywhere between 500 to 800 tons per year since 2020. So I want to give an overview of our facility, just to give you kind of a size reference of what we operate with. So you can see the dimensions here. Our facility is smaller than 70 foot by 70 foot. We have a tip floor, and then we also have a processing floor. So you can see on the left side of the slide here, those are the 2 pieces of equipment we utilize in order to load our machinery into the hopper. We have a mini loader as well as a fork truck that has the forks that will rotate 360 degrees. Sometimes we get the packaged material that comes in is strapped down to a pallet, and it's sometimes easier to dump it in rather than separate it all out, pick it up with the loader, and then load it. A good example is in the picture below. Sometimes we'll get material in these cardboard boxes. It's easier sometimes either if they're strapped down, dump them right into the hopper, or put them on the floor and then scoop it up. On the right side is a preview of some of the processing equipment we have. This diagonal piece of equipment are twin screws. That's how the food waste is brought into our food depackager. I got a better picture on the second slide, so I'll go over what that does. From there, it gets processed, sent to our mixing tank, which is the big picture on the bottom right. That's where we make that organic slurry before it is sent next door to the wastewater treatment plant. All right, so we bought this equipment through Scott Equipment. They're located in Minnesota, and at the time, which was 2018, their biggest and baddest machinery was this Thor, and that has been, I think, overall has been a very good piece of equipment for us. Inside this, you can see there's doors to contain everything, but there is a shaft that weighs approximately 10,000 pounds, and it has between 50 and 60 swing hammers inside of that. These hammers each weigh about 65 to 70 pounds each, and when we fire this machine up, they all swing, and that is how the process of depackaging the material comes through. On the bottom portion of this Thor, there are various size screens, and that is how all the food waste is like pushed through. I'm sure everybody's familiar with the like a Play-Doh machine where you put the Play-Doh in and you push it through and it comes out in different shapes. That's basically what we have on the bottom. Then in the bottom left photo, that is just the trough where the food falls into before it gets pumped into the mixing tank. Here's another close-up video or a photo of our processing on the right. Like I said, we've done some upgrades to our equipment here. So for instance, this pump we've upgraded over time. There's another pump in the back that we've upgraded as well. It's kind of been an ongoing process for us at our facility. And the bottom middle picture is just our loadout. Inside there, we have a pump, and that is where the force main goes from the our facility over to next door to the digesters. All right, we utilize a batching process. Like I said, we put it into the mixing tank, and then from there, we're looking for a certain percentage of solids. Everything we've tested to this point has been under 10%, and that's what the Oneida County Sewer District requires for us to put into their digesters. Like I said, we have about 1,500 feet of underground pipeline. We discharge, this year we've averaged 22,000 gallons we have sent to the digesters this year. In order to help promote more SSO being brought to our facility, we have a decreased tipping fee. Our normal municipal solid waste is $16 per ton, and we offer a $20 reduction per ton at $40 a ton for potential customers to drop off at our place. Currently, we have 15 haulers to provide SSO to our feedstock. We have regular customers that come in at least 1, 2, 3 times a week. And then we also have ones that come in every other week or once a month based on what their needs are. Another bottom picture here in the bottom right, that is the loose grocery store waste we receive. One of our big suppliers, one of our haulers brings in food waste from Hannaford. If you're familiar with the Northeast, that is a grocery store in our area. So you can see various items in there. There's produce, there's bakery items. We even get deli meats in there as well. All right, a little overview of what was going on with the Oneida County Sewer District. Original facility was 1972 and has a design influent flow of 54 megagallons with a peak wet weather capacity of 111 megagallons. The digesters were part of a massive upgrade project to their facility in 2016. And that is when we started doing our feasibility studies. We knew New York State was coming, the DC was coming down with food waste regulations, and we said, hey, this is probably a good time to take advantage of our next door neighbors putting in the digesters. Previously, sewage sludge was incinerated, and then the ash was sent up to the landfill. Now they currently are using generators to use that gas. In 2007, they entered an order of consent to eliminate sanitary sewer overflows at the Sequoia Creek Pump Station, which has led to their major upgrades to their project. So this has been going all the way back to 2007. The air quality regulations had changed at that time, and the facility was in drastic need of upgrades for the wastewater treatment plants, which seems to be a pattern for most of the wastewater treatment plants up in our area. They had several contracts that were associated with that project. Like I said, this construction spanned over about 8 years. They started in 2017, and they just finished up the last portion of their projects last year. This included new anaerobic digesters, which we've been going over, energy recovery, as they do have several engines, power production right now for up to 50%. That was the original design, with designs to increase that with more generators. Additional heat recovery, which is used for the anaerobic digesters. They decommissioned all of their incinerators. They're no longer burning any of the sludge. Septic receiving facilities for outside waste, including food waste for our authority. So that building actually right in the middle of your screen is where our material goes to. And then they had miscellaneous upgrades throughout their facility. They utilize a fog screening machine to screen incoming slurry from the SSO PF. That's just in case anything slips through our system. The fogs that they have screens that are 5 millimeters wide. The screens that we utilize can only break down that material to about 3/8 of an inch. Sewage sludge is continually fed into the ADs. while the SSO is kept in a 50,000 gallon tank, there's a 50,000 gallon storage tank underground underneath that building, and that's where we directly pump into before it gets bled into the anaerobic digesters. The SSO provides a high chemical oxygen demand of volatile solids, which the bacteria in the digesters break down and turn into methane gas. And then with that methane gas, currently SSO that we provide, that's just from our facility, accounts for 18% of the AD feedstock, but is also responsible for just under a third of their methane gas production. That's been increasing since we've been taking in more SSO material. We've been able to get that up. So we're always hoping that we have more SSO coming in so they can increase those capacities. The digester gas that we talked about, that is used to produce electricity for their building. Originally, part of their program was to only cover 50% of their power needs. But if you look down below, they are, since adding 2 more micro turbines, they're up to about 75% of that wastewater facility's energy demand they are covering with their generators. All the energy produced is internally used on site. Like I said, 75% of their needs are met. And the exhaust heat from those generators is used to maintain the digester's temperature. So those, I know this is recorded, but if you need to get in touch with any of us, if you have any questions, you can contact any of us through that information.
Andrew, thank you so much. Stay with me for a moment, because before we go to the questions for all the panels, all the presenters, one question for you, Andrew: what percent is non-organic material from the depackaging? Right, you've got your food slurry,
Yep.
and you have your packaging waste.
I have to double check the newest numbers, but I think we're between 10 and possibly 20%. I think it's closer to that 10% though. Those depackaging machines are extremely efficient in removing that residue. And then certain residues that we might have, like say for instance, we get a load of aluminum cans, we can separate that out and collect that. Sometimes it does get a little messy with those packaged items because you're mixing plastic, cardboard, film plastic too, not container plastic, and it's hard to get some of that stuff out of there.
Okay. Wow. So we do have some questions from the audience, and then I have some questions too. But we have good time remaining, so let's respond to questions from attendees. So I'm going to start with the heavy one, because several people have asked the big question about PFAS. So what happens to PFAS? That's apparent in sludge, and then when you co-digest with food waste, what happens with managing that material? Who would like to start in answering the big question about PFAS?
Well, I'll just start out by saying it's complicated and the research is ongoing. And so we don't really know a lot of the answers, but I did see a bunch of questions in there about PFAS, and I was going to make a joke and I decided not to at the beginning when I started talking about co-digestion, is why would you contaminate biosolids with food wastes? But because there are also PFAS in food waste. But just to take a step back, we really only have 3 ways of managing these materials in the end: landfilling, incinerating, and beneficially using them, recycling them in some way. And none of those options deal with PFAS that we know of. There's maybe some potential for incineration, but I think it's important to take a step back because and focus on the benefit, the costs and the benefit, or the risks and the benefits. And if you take a look at the levels, the PFAS levels in biosolids compared to other waste materials, certainly I don't have any concern in doing the anaerobically digesting it. As I said, the research is still out there. I think there's some transitions or transformations going on during anaerobic digestion. There's some exciting research going on with like pretreatment processes. Maybe Jane knows about hydrothermal carbonization that does show some potential to address PFAS. So there's a lot of research, a lot of smart people putting their brains on this. but I don't think PFAS is a reason not to do co-digestion.
Mhm. Mhm. Yeah.
And I could just add, that this is something we talk about a lot, right? Because we have this beneficial use program, and New York City produces about 1,300 tons a day of biosolids, right? And if you look at the climate benefits of beneficial use compared to landfilling it, like it's really, really significant. And we're testing our biosolids right now for PFAS. We're hopeful that the concentrations will be low because most of our our waste stream is coming from residential, commercial. We don't really have a lot of industrial users. We have some, but we have not a lot of industrial users within our sewer sheds. But we also have a really robust industrial pretreatment program. And like we've been here before with emerging contaminants, heavy metals in particular was an issue for a while. And just like Michigan did, it sampled all of the biosolids across the state and identified that there were a certain number of communities that had higher concentrations. And then they looked upstream and they were really able to identify like where it was coming from and actually able to have really significant reductions in PFAS concentrations at those particular facilities. And so, we don't want to give up on the beneficial use program. And so we're hopeful that like we can take a really kind of measured approach like that to, and that eventually PFAS, will be banned, right? Like as something being used, because it really does disrupt, recycling and circular economies.
Mhm. Mhm. So, Jane, what I heard you say that most of the material is coming from the residential stream and maybe some industrial, but what I'm gleaning from that, how important it is to look upstream, maybe at the contracts and look at some of those industrial users. I recall that I read an article about a wastewater treatment facility that did look upstream and questioned some of the industrial users and suggested that maybe they don't take feedstocks or, cut off those heavy industrial, chemical users as a way to, kind of reduce the risk of the concentration of PFAS.
Yeah, and if it's coming from like one particular user or two particular users, chances are it's much more concentrated, right? Than like by the time it hits like the rest of like the sewer flow, right? And so it would be much more economically feasible and reasonable for them, and actually just technologically feasible for them to be able to reduce the amount of the PFAS, through industrial pretreatment and before it ever like hits our sewers.
Mhm. Okay. All right. So that's kind of the PFAS questions. There were a couple of questions regarding pre-processing of feedstocks. Andrew, you touched on your DPAC. Maybe we could talk a little bit about pre-processing and reducing or kind of removing, the visual contamination.
So when we set haulers up or a customer that might come in, we let them know what we can and can't accept. Typically, we have them either if they're local, we can go out to the sites, or they can send pictures of the material that they have. Most everybody who comes is either going to be loose, like grocery store waste, or it's going to be prepackaged items that come in. If something does come in, which it has in the past, where they were sending us like 5-gallon pails or extra bags. We're trying to keep as many bags out because they are tanglers, just like with any recycling facility, they are tanglers for our machinery. If we visually see something, we will let them know that it can't be in the system. If we can take it out, we will. If not, then we end up saying, this is mostly trash you're bringing us, so it's going to be charged at MSW rate, and then we're not processing it. But that's with any facility. If somebody tries to do that at a recycling facility, it's the same thing. If they try to give us 75% MSW when they claim it's recycling material, it's the same process. So that's the visual check we have for it. We've had quite a few material come through there. Certain things we aren't able to take, like big vats of liquid. We can't process those very fast on their own, but we have had pallets and pallets of beverage cans that we tend to mix in with the grocery store waste just to kind of soak up some of that liquid and not have it, one big slug of it going through the system. And I did see somebody asked about the recycling of plastic cans and Ferris cans. That machine actually does do a very good job about separating it. Yes, we will have some residue on those plastic or those cans. It's mostly the packaging that is the issue when we come to recycling that material. If we just do a load of yogurt containers, I'm sure everybody's familiar. We've got Hood and Chobani in our area. Those actually get separated very easily. You'd be amazed, even with the weight of those hammers. It's almost like an intact container that comes out the back. It's crushed a little bit, but it comes out the other end pretty much cleaned out. But it's just like with any other recycled waste. I mean, I don't know what the percentage is, but I doubt everybody completely cleans out their cans before they toss them in their recycling bin. So.
And I think, Jane, there was one, specific for you about elaborating a little bit more on the pre-processing screening and is there AI involved?
No, there's no AI. And in fact, it's a kind of a two-step process in that so they have a five-step process where they're kind of cleaning out contamination, and it's a proprietary process. So I actually don't even have all the details, but they have a debagger, and then they kind of go through this step where they're able to take out most of the contamination. I will say during the fall and kind of in certain times, like because New York City co-collects yard waste with food waste. And so if they have like whole bags of leaves or other yard debris, they actually handpick that out right up front. And then that goes to compost, right? They have separate composting contracts where that goes. And then the rest of it, if it's just kind of integrated as part of the source separated organics, then that kind of ends up coming through. So that's not like contamination per se, but it's an organic material that's probably better suited for composting than it is for co-digestion. And so rather than fill up our digesters with leaves, it makes sense for all of that just to go to compost. And then there's a certain amount of material that does get mixed in, of yard debris and stuff that gets mixed in with ours, but it's not a tremendous amount. One of the things I didn't get to mention during my talk that I think is really pretty cool is that Waste Management has a pretty robust business in collecting brown grease from restaurants. So it's like yellow grease is something that's actually has a great market and people make biofuels from it and stuff. But the brown grease is actually kind of notorious for being difficult to recycle because it's watery and it's oily and it's not like kind of really great in one way or the other. But they collect that and they use that material to thin down the food waste that they've slurried. And so that's actually how they get it to the concentrations to make it pumpable. And it's great because it's also full of oils, which, the biogas yield on fats is like, it's not 100%, but it's very close to 100%. And so, it's actually like a really great solution for the kind of a traditionally very difficult material to recycle.
Very cool about the different yellow and brown fats. I think that's pretty interesting. I still have some more questions from the attendees, but I'd like to ask a general question for everybody. What's the motivation? What motivated your operations, your county, to explore co-digestion as a solution?
I'll go first since everybody else is muted right now. But it goes back to, our feasibility study plus those upgrades due to new regulations at our neighbor. We do have a green waste compost site, but we lack the manpower plus the, infrastructure in order to actually compost any of that food waste. And it made more sense for us to put this facility in and then utilize those digesters. And then when we brought that up to the sewer district, they were very on board with it for us to send that material to them. I think it would just happen to be a good coincidence for them going through the upgrades and the upcoming DEC regulations that allowed us to take advantage of our situation.
Mm-hmm.
I just wanted to add, Deborah, because I think these two utilities are obviously leaders in looking at using anaerobic digestion. But somebody was asking a question about they've been trying to work with wastewater treatment plants to accept food waste, and they're slow and reluctant. And that's more the common theme you'll get from operators, because traditionally they're all about compliance, permit compliance. And if their facility is operating well the way it is, they're not going to mess with it. So it might take some persuading and sharing of information, like what they can get out of it. And then you might be able to persuade them. There is definitely some benefits for the wastewater treatment facility in doing this. So
Yeah, one of the things that, we're able to we're able to process a tremendous amount of material locally, right? And for a city like New York that's producing so much food waste, right? Like, it's to be able to handle that locally and like reuse it locally. This is like a really kind of great model, we believe, for kind of creating a circular economy. But there are other kind of advantages to sometimes having biogas beneficial use. Like, it can be pretty expensive for a utility, and like Janina covered in the beginning, there's a whole lot of reasons why we anaerobically digest that have nothing to do with biogas, right? And so it really is a stabilization and mass reduction strategy, and then biogas is kind of this happy byproduct that comes from it. But because of that, there's a lot of facilities that aren't beneficially using all of the biogas. There's a lot of flaring that happens. And sometimes the economics don't always pencil out for having a cogen or having some other type of beneficial use. And so being able to have this additional food stock that does digest so well and create so much biogas can actually make those kind of really great centerpiece, biogas beneficially used projects move forward, because there's like an economy of scale that you're able to achieve by increasing the amount of biogas that's produced. And so that was kind of another benefit that we were able to, have that agreement with National Grid, that they were able to build the gas to grid system at our facility. Part of that is like we're able to really kind of fill that up with using the food waste in addition to the wastewater sludges.
Mm-hmm. And just to carry that thought a little further, Jane, I don't know if you've answered it, but let me just ask a question regarding the DEP's vision for the use of biogas from co-digestion.
Yeah, and I think I kind of touched on this a bit in the presentation, but we really do see that like there's New York State is really trying to push away from combustion, which is great, right? I think that there's there's a whole lot of good to be done with like electrification of heating needs and reducing combustion and the emissions that come from that, not to mention the carbon emissions. But there is a certain number of users that are just going to be it's going to be very, very difficult for them to get off of fossil fuels. And so we think that there's an advantage here that we can provide this material that they're able to use, that they're no longer contributing to the carbon cycle. And so that it's like a net carbon, negative or neutral fuel. And then at some point, we think that the electrification, technology, heat pump technology, is going to improve to the point where they're able to achieve higher temperatures through heat pumps. And, lighting methane on fire might not be like the highest and best use of methane moving forward. And so DEP is really paying attention to, are there other, higher and better uses that we should be keeping track of? And so we're watching the industry, trying to see like the methane and its precursors as like volatile fatty acids, like they're terrific building blocks for making other materials. And so we're really following the research and the work that's being developed in that area, that we could be making, all sorts of materials, out of this, that it doesn't necessarily need to be gas.
Mm-hmm, mm-hmm. And related to that, and maybe Janine, you can also respond to this, a question from an attendee, with the recent pullback of federal funding, in particular for RNG projects, are there funding sources that you might suggest or that clients or members are utilizing for new RNG projects? What does that look like through your crystal?
Yeah, I've seen some pretty creative financing with RINs and RECs and other things. I don't know what the status of those credits are either. But I think a lot of times just the economics, when you do the math, the return on investment for this type of a project is going to be pretty good under 10 years. So I think Yeah, I definitely, the grants and the loans help facilitate it, but I think there's still, you can still find a way to finance them. I'm hoping.
And that does lead to CapEx and OpEx question that I saw in here, and maybe Janina as well as Andrew, you might want to talk a little bit about looking at the capital and the operational expenses, if you can. And,
Yeah, I mean, the capital expenses for sure can be big, but I feel like we already have a lot of sunk capital, and these the infrastructure can last a long time. And the operating side, I'll just say that anaerobic digestion can actually reduce some of the operating costs. So, but I'll let the operators speak.
Yeah, no, I mean, operated, the equipment is fairly expensive for this because it's such a niche use for it. We were able to secure some DEC grants through Oneida County for our construction, which helped out quite a bit for the construction of the facility. Those were available at the time, which we were able to take advantage of. Upkeep, we have had to change out equipment just because some of the equipment is just extremely expensive for spare parts. So we went to a little more durable pumps and changed up how the way we're processing in order to save on some of those replacement costs too.
Mhm. Anything? Go ahead, Jane.
Yeah, I mean, the big cost of the digester is if you're leveraging, existing digester infrastructure, right? I mean, that's kind of that's the big advantage here, right? Is that we already have this, existing infrastructure and expertise, which is terrific, right? But there are definitely costs around, both certainly the pre-processing and then the feed and system, infrastructure, and then also the beneficial use of the biogas. And there's a lot to be considered there. We had built our own in-house models in order to model that out, and also they really calculated the true cost of DEP for doing co-digestion. Like it's not necessarily a slam dunk. Like there are things that you need to consider. It's it's the energy that you're using. It's with the digestate, the solids disposal, biosolids disposal is actually very expensive in the Northeast. And then also, there's also nutrient, like we're closely monitored on nitrogen, right? And so the nitrogen costs, like as far as that getting introduced into our system, like there's a lot to consider there. And so we built our own models around that. But in the end, it penciled out that it made sense for us to do it. But it is something that really does need to be strongly considered.
Mm-hmm. Mm-hmm. So we talked a little bit about capital and operating expenses. I had a technical or operational question for you, Andrew. How has diverting SSO, source separated organics, from landfill, how's that impacted or had an impact on operations for the authority and for the counties?
There is a decrease or increase, I guess, in airspace for our landfill by diverting the food waste, which is good. We haven't seen, because the amount of generators is so small in our area, because like I said, we serve 300,000 residents and our biggest city is 60,000 people. We haven't seen too big of a hit in our gas generation at our landfill. Like I said, we've got those engines up there which create their own power, and we've done our research into possibly switching to renewable natural gas. So that's all in that realm. So we haven't seen at least for airspace, we've gained a little bit of airspace from it, but it hasn't drastically impacted too much as of yet. I think as we get closer to those newer deadlines with the increased, I guess will decrease. So like the 1 ton per week generators, we're gonna have more and more restaurants in our area, smaller grocery stores, the mom and pop establishments. I think they're gonna provide more food waste for us, and I think that's when we're really gonna start seeing that impact on our system. Plus, I said earlier too, that increased energy efficiency for the wastewater treatment plant. They've already increased their numbers. We were at 20% when we first started, and now they're up to like 30% of their energy is coming from our food waste. So I think that's the major impact right now.
Mm-hmm. Yeah, no, so I have some other technical and operational questions that I wanted to ask, but we are getting a lot of questions from the audience still regarding PFAS, and maybe a way that we're not sidestepping this, but let's talk about the land application and getting that digest state mature or treated prior to land application. And one of the questions that I'm asked a lot is if states or areas prohibit land application, what are we going to do with that digestate, that the composted biosolids or the digestate coming out of the AD operations? So let's dig into that a little bit. We have some time, so I think we should really talk about the issue still with land application with potentially concentrated PFAS in the digestate.
Well, I'll just start out by saying not all biosolids should be land applied. And that's operators are keeping track, doing testing. There's some good regulatory programs out there right now, like Michigan, New York State has a 20 part per billion limit on PFAS, I believe. Jane, you can correct me if I'm wrong. So that's one thing. There's many options. There's 3 options, and we have to use all 3. If we could really use 4 or 5 options at this point. And I forgot what the other point I was going to make about that.
Take your time. We want to respond to this question.
So currently, as far as PFAS, we don't directly treat for PFAS. We are making financial, I guess, allotments for the future. I know DEC is still coming up with their ideas on what we do need to do with the PFAS. It started off as just treating it at landfills, but somebody mentioned earlier, we got to make sure we're taking care of the upstream too. And I think wastewater treatment plants too are looking at possibly including that with their system. There's because they are everywhere. It's hard to nail down what it is. In all of we go to these conferences all the time, and everybody's got their different idea of how to treat the PFAS, and there's pros and cons to all of them. And it's kind of hard, if we do a bubbler, is that going to be, is it going to go back in the landfill after? How do we put it back in the landfill? Because we're going to be eating up the space. Some of them are like, well, you can encase it in concrete, and then we're taking up even more airspace in our landfill, which is opposite of what the project wants to do. We want to maintain that airspace for as long as possible. So we're keeping our eye on it. It's obviously a major issue for us and for everybody. And we want to make sure that we're following regulations, and we want to. Currently, all the biosolids that we have coming from the digester are going back into our landfill, and then we treat the leachate coming off the landfill at the wastewater treatment plants. So that's currently how we're taking care of it, and we obviously, anything changes, we will be on it. Like I said, financially, we are preparing for, because it's going to be a large investment, I think, across the board for us to do anything with that. I see a question in there. I'll just jump in real quick before somebody comes in. Yes, we do charge for food waste collection, and it is at a reduced rate from our MSW. Our current MSW per tonnage is $60 per ton, and it's a $40 per ton rate currently right now for food waste.
Mm-hmm. Mm-hmm. Okay.
Yeah, I'm not a food waste expert, but I don't know what options are out there for dealing with food waste. But I'm gonna guess it's the same situation that we're in, that there really are no destruction technologies out there. I think we're doing a pretty good job sequestering it, like at the landfills. But I think that we need to talk about it. We need solutions in some cases at the back end, but ideally keeping it out of the wastewater to begin with is the best. And I saw a question about microplastics there too. Yeah. So treatment facilities in general do a lot better job removing microplastics and PFAS, but guess where it ends up? In the solids again. And again, it could limit beneficial uses. So the source reduction, source elimination is really where we need to go. I think we can all agree on that.
Mm-hmm.
Absolutely.
Yeah, it's a question that comes up all the time, and certainly I get asked about PFAS, and we all know that PFAS is ubiquitous. in our rain, in our soils, in our bodies. It's an unfortunate situation when we look at the way that we operate commercially. I think there were a couple of questions regarding, again, the digestate pathways. So we're not dealing with cake. We're literally dealing with a dewatered digestate. What is your output? If I may, just linger on the question of digestate.
So our digestate is, it goes to multiple locations, right? We have, we don't dewater at Newtown Creek. We dewater at, we have other centralized dewatering facilities in New York City, located at other wastewater resource recovery facilities. So it could go to one of two of those facilities where it gets dewatered to about 26% solids, and then it goes off from there to post-processing, either composting, drying, alkaline stabilization, and then it gets land applied. We have a certain number that also gets currently gets landfill, but we're looking at options for land application for post-processing and land application of that. And then, like I said, there's another stream that we send digestate directly to the Passaic Valley Sewerage Commission, and then they run their Zimpro process on it, and then they stabilize it and to make landfill daily cover out of it.
Mm-hmm. We do have go ahead, please. Someone? Or is that I've got
you, Deborah, you're echoing.
I've got an echo, I think. Megan, are we a 3 o'clock wrap up? I was just double checking.
4 minutes left.
Only got a few minutes left. We could probably go another half hour. We still have some questions.
There were a couple questions in there, Deb, about collecting food waste through the collection system. Jane, do you want to talk about that at all? Kendall and I have an ongoing discussion. If we could collect the food waste from the incinerators and separate them out, yeah. I'm all for that. Send it to New York City's New Creek.
Yeah. I agree
the problem.
With you,
what are the problems? Tell them what the problems are when you dump it down the collection
There's
system.
A couple, right? And so, right, if it be collected and put right into the digesters, that's terrific. But as it can actually, kind of clog up the collection system, right? We can get fatbergs and things like that, which is definitely a concern amongst our Bureau of Water and Sewer Operations. And then additionally to that, if it comes into the head of the plant, it's going to go through, primary treatment. So anything that's like solid will settle to the bottom, and fats, right? Like those will go to the digesters, but everything else that's kind of dissolved is going to end up in our secondary system. And we're going to use a tremendous amount of energy trying to burn that up, right? In order to be able to meet our discharge standards. And so because of that, it's just, what you'd rather do is bring it right over to digesters, and so that you can extract all the energy instead of using a tremendous amount of energy. I mean, there are situations like it could be, a supplemental carbon source to enhance denitrification. There's certain niche uses where it could kind of make sense. But, from our standpoint, we have an old collection system. We really kind of want to, kind of make it as clean as possible. And then we think that we have all of this digester capacity, and it makes sense to just direct it right into the digesters.
Okay, yeah. So I think I need to kind of wrap us up, and I want to thank everyone for attending, and a special thank you to our speakers for this very engaging and insightful discussion. It could go on, but we're scheduled here till 3 o'clock. So co-digestion is part of a multidisciplinary approach for managing organics. Helping to reduce landfill dependence and managing methane emissions, while unlocking value from organic waste. And I think as we move forward, staying open to diverse technologies and supporting utility-led innovation and embracing systems level view of organics management will help build a resilient and low carbon communities. And I just wanted to kind of close on that and maybe toss it back to Megan for final comments.
No, thank you, Deborah. I think this group was really excellent. I mean, you're the perfect people to speak about co-digestion. I hope that we answered a lot of questions. And thank you, Deborah, too, for guiding all of our experts here through this webinar. And thanks for all who attended. We will do our best to get back to you on the questions. The presentations and recording will be provided as well, and you should get contact information for all our speakers as well. All right, have a great weekend, everyone. Thank you again.
Thank you so
Thank you.
much.
See ya.
Appreciate it.
Bye.
Bye, everyone.